All right, this video is for learning target 1 in the polynomial unit. We're just working with monomials in the first target, so we're going to be working with a lot of multiplication and exponents and all of the rules that come along with it. It's an algebra 1 concept, broken it down into properties. You can kind of pause the video and look at them a little bit. I'll touch on a few of them real quick. Like, for example, property number 1, if you were multiplying 5 to the 1 times 5 to the 2, take your calculator and verify it. 5 times 5 squared. It's going to give you 125. But this property, you're applying the same base, a and a, and you take the exponents, m and n, and add them. So according to the rule, that number should be the same as 5 cubed. And if we type 5 cubed in, yeah, we see that it is the same number. And we could do this for all of these rules one by one and show how they work numerically, but that's not the purpose of the video, since this is an Algebra 2 video, and in Algebra 1 you covered these. So it's just kind of a reminder, refresher. But like just looking at one of the other properties, number 5, if you are cubing a 2 and an x and a y squared, according to property 5, you cube the a and the b. So in this case, there's actually 3 things in the parentheses, so you cube them all. You cube the 2, you cube the x, and you cube the y squared, which involves property 4 down here at the bottom. Property 4 says when you have a power raised to a power, you multiply those powers. So back up here, that y squared cubed becomes y to the 6. So anyways, that's just kind of an introduction to the properties. There are some negative exponent properties here. I do want to explore those with numbers, and then work a few problems that involve multiple properties. The negative exponent property, let's just look at 5 to the negative 2. Calculator would say that that's 0.04, or the fraction 1 over 25. Now, if we look at this property, it's our a is the 5, our negative n is the negative 2. It says take your 5, put it in the bottom, change the negative 2 to positive 2, put a 1 on top, which is 1 over 25, the same thing the calculator says you would get for 5 to the negative 2. So anyways, the negative exponent property, I wanted to show you the number side, but now let's work a few problems. Example 1, this one's basically property number 5. You cube the 3, you cube the x squared, and you cube the y to the 4th. When you cube the number 3 cubed, it becomes 27. When you cube the x squared, you have to use that property 4, which says multiply your exponent, 3 and 2, so you'll get x to the 6. Same thing with the y. When you cube the y to the 4th, it will become y to the 4 times 3, y to the 12. Number 2, it's actually using property 2 here, where you've got the same base being divided in a fraction. It says subtract your exponents, but I really don't use that property. Instead, I use this version, x to the 5th over x cubed, this example. I would divide those x's. 5 divided by 5 is 1. 2 divided by 2 is 1. 3 divided by 3 is 1. So each pair of x's, x divided by x, reduces to 1. Reduces to 1, reduces to 1. And that leaves you with 2 x's in the top of the fraction, or x squared. So I use that version of the property, and it'll kind of be illustrated here. Well, no, it won't be illustrated in this problem. Let me change this problem so it will be illustrated here. I'm going to change this y to the 5th. All right, now it'll be illustrated. So when we look at these x's, I see 5 x's in the top being multiplied, and I see 3 x's in the bottom being multiplied. So each pair of x's is going to cancel to 1, reduce to 1. Oops, I skipped one there. It's okay. There's still 2 x's left in the top. So our final answer is going to have 2 x's left in the top. The y squared divided by y to the 5th, I see that as 2 y's in the top and 5 y's in the bottom. So those 2 y's are going to cancel, and those 5 y's are going to reduce to only 3 left. So you're going to have y cubed left in your denominator. And then last, the z to the negative 3. Well, just a minute ago, we looked at 5 to the negative 2. X to the negative 2 would be 1 over x squared. X to the negative 3 would be 1 over x to the third. Z to the negative third would be 1 over z to the third. And if you multiply 1 over z to the third times the existing fraction, z to the third would be in the denominator. Because when you multiply the top by 1, this right here is 1 over z to the positive third. When you multiply 1 times x squared, it doesn't change anything. When you multiply z cubed times the y cubed that was there, you end up having a z cubed in the denominator. So that'd be your final answer. I'm going to pause the video just for a second. Okay, sorry, I had to pause the video for just a second because I wanted to pull this up, because at some point the question will come up, when am I finished? When is a monomial completely simplified? And it's simplified when it meets these 4 requirements. There are no powers of powers, so if there's ever an x squared raised to the third, you need to change it to x to the 6th, multiply those. Each base appears exactly once, so if there are x's in the problem, there needs to be 1 x in your answer. If there's if there's multiple z's in the problem, there needs to be 1 z in the final answer. All fractions are in simplest form. That's obvious. If it's 3 over 12, that needs to reduce to 1 over 4. And then there are no negative exponents. So if you ever have an x to the negative 2 in your answer, it's in the top of the fraction, you need to move it to the bottom and make it x squared, and vice versa. If it was say it was a y over z to the negative 2, your final answer would be y in the top, z to the positive 2 in the top of your fraction. All right, so anyways, we're going to use that from time to time, but it's basically use all of the properties that are on this front page. I'll show it again, slide through, pause it as you need to, or go to the beginning of the video, but use all of these properties to reduce a monomial. All right, we've got 3 more examples. Number 3. First step is property 6b. Property 6b, and it says, you have a fraction raised to a negative exponent, flip the fraction and change the exponent to positive. So our first step here in number 3 is to flip this fraction, 4a cubed on the top, b on the bottom, and change the negative 2 exponent to positive 2. And then I'm going to use a combination of properties 5, 4, and 6a, which basically says you square the top of the fraction. This is 6a, square the top, and you square the bottom. And then property 5 would say square everything in the top, so square the 4 and the a cubed. And property 4 says if you have a cubed squared, you multiply the exponents 3 and 2. But the bottom line is, when you have a squared outside of this fraction, you square everything. So the 4 becomes 16, the a cubed, when it's squared, becomes a to the 6th, and b squared becomes b squared. All right, number 4. First thing I like to do on a problem that has negative exponents is move any of the negative exponents from the bottom of the fraction to the top, or vice versa. So I'm going to take this a to the negative 2 and move it to the denominator, and it will join the 4 a's that were already there. So now there's going to be 6 a's in the denominator. A to the 4th times a to the 2nd, there's going to be 6 of them. Same with the b to the negative 2. I'll move it to the top. So now there's going to be 2 more b's in the top of the fraction where there was already 3. So now there's b to the 5th. And then last, c to the 0 using property 7. C to the 0 is just 1. Now there's some confusion with that, so I want to clear that up real quick. It's not c, it's the number 1. And if you test that theory in the calculator, what does anything to the power of 0 give you? 5 to the 0 gives you 1. 3 to the 0 gives you 1. Parentheses, negative 1 divided by 5 to the exponent 0. It's always 1. So there's no base left. There's no number other than 1 remaining when you reduce c to the 0. Okay? So c's gone. And like we said before, there's now 5 b's in the top and there's 6 a's in the bottom. The last thing to reduce is, according to this, all fractions are in simplest form. We need to deal with the 5 divided by 15. Like any run-of-the-mill fraction, 5 and 15. They share a 5, so 5 becomes 1, and 15 reduces to 3, so this final answer will be 1/3, the fraction part. So final answer, b to the 5th over 3a to the 6th. All right, last question, number 5. When I see a problem like this, you're still bound by the order of operations. I should have probably mentioned that by now, PEMDAS. And if there is ever anything you can do in the parentheses, you will want to do what's in the parentheses first to simplify that. But the first thing to do in this problem is to square everything in both parentheses. So one by one, the first one, 3 squared becomes 9. A squared squared becomes a to the 2 times 2, a to the 4. B cubed squared becomes b to the power to a power again, multiply them, 3 times 2, b to the 6. Now, just since I haven't mentioned this, b cubed squared is the same as b cubed times b cubed. If you think about it, that's how you square something, itself times itself. That's 3 b's times 3 more b's, that's 6 total b's. So the shortcut is just do the 3 times the 2. And again, that's why they're called shortcuts on the front page. All right, now the next parentheses, when you square a -2, it looks like this, squaring a -2, so it becomes 4. When you square the a to the -1, it's still the same shortcut. Multiply your -1 times your 2, so a to the -2. And then b to the 4th raised to the 2nd power is b to the 4 times 2, b to the 8. You've got multiple options to fit. What I would do in this situation is notice that I'm multiplying, all these are multiplication, and you can multiply in any order. I'd multiply the 9 times the 4 and get a coefficient of 36. And then I'd look at that a to the 4th and the a to the -2, and instead of putting a to the -2 in the denominator, I would reach back and grab the first property, which just says if you have a to the anything being multiplied by a to the anything, you multiply those by keeping the base and adding the exponents. So in this situation, I'd keep the base a and add the exponents. 4 plus -2 becomes 4 squared, or becomes a squared. And then b to the 6 times b to the 8th, b to the 14. All right, that just barely scratched the surface of these properties and the multiple ways you'll use them and the importance of parentheses and where they go. So there's quite a bit of homework to practice with this. So make sure that you try all 52 of them. And if any of them give you troubles, we'll look at them together. But you know, this is sorry about that. This is just a target that takes practice. It takes problems in different situations for you to use these properties and see how they work before it all kind of comes together. But that's learning target 1.